right, so this graph here that we are looking at now, the first thing I want you to notice is that it does not have a line or a curve. And graphs that have distinct points, like the one that you're seeing now, is called a discrete graph. All right. So the graph that we had in the first example is called a continuous graph. And by definition, a continuous graph is a graph where the points are connected, indicating that the domain and range are sets of real numbers with no breaks in between. But a discrete graph data consists of individual points that are not connected by a line or a curve. All right. So that means that there are breaks. So with a discrete graph, you may skip numbers. It may not go like 1, 2, 3, 4, 5. It might go 1, 3, 5, or whatever. So it's not necessarily a consistent set of numbers. All right, so looking at this graph here, we are going to figure out what's the reasonable domain and range. Remember, reasonable means if it's a real world situation, it has to flow, right? It can't. If we're talking about miles and time, things of that, we reasonable wouldn't be negative numbers. So that's what I mean. All right, so looking at these data points, when you're looking at the domain of a discrete graph, you really need to find the coordinates of each point, all right, for the domain and the range. So if we look at this first point here, that point is 0, comma 1. So I'm going to just highlight all of the points, okay? This second point here is 1, comma 3. The third point looks like it is 2, comma 5. The next point here is 3, comma 7. And then the last point is 4, comma 9. We know that all of these values are x, comma y's. We know that x values are the domain. So let's look at all of the x values. We have 0, 1, 2, 3, and 4. So for my domain, I will put 0, comma 1, comma 2, comma 3, comma 4, and close bracket. For my range, I'm going to look at the y values, and we have 1, 3, 5, 7, and 9. So 1, comma 3, comma 5, comma 7, comma and 9, close bracket. And that is my reasonable domain and range. Now, we also could move further and describe a real world situation that matched the graph. You could pretty much make this up for yourself, but one that I would come up with is this. We could say that a bowling alley charges $1 to rent a pair of shoes, all right, and $2 per game for up to 4 games. All right. A bowling alley charges $1 to rent a pair of shoes and $2 per game for up to 4 games. That's a reasonable, real world situation. Now, when we're looking at our independent and dependent variables, all right, independent and dependent variables, remember that the number, so if we're talking about this particular situation that I just said, a bowling alley, right? So that means the number of games would be the X. All right. And the amount charged will be the Y games. I mean, the Y values. Okay. So the number of games would be the independent variable, and the dependent variable would be the amount charged. The amount charged depends, you see the word? The amount charged depends on the number of games played. So if you only play one game, then you would only pay $3. Okay. If you play one game, you will pay $3. If you play two games, then you would pay $5. Okay. So the amount of money charged depends on the number of games played.